Dear students, today we are going to start with Organic Synthesis 2nd, Elective Paper 6th, Paper 505, Group 2nd, Unit 4th. Ring Synthesis. The syllabus is Saturated Heterocycle Synthesis of 4, 3, 4, 5 and 6 membered rings, Aromatic Heterocyclic in Organic Synthesis. The reference books are Designing Organic Synthesis, S. Warren Y. The second is Organic Synthesis Concept, Method and Starting Material, J. for Hope. Third one is the Some Modern Methods of Organic Synthesis, Carruthers, Cambridge University Press. The fourth is Advanced Organic Chemistry, Reaction Mechanism and Structure by J. March Willey. And last is Principle of Organic Chemistry, Part B, F.A. Cray and R.J. Sundberg, Planium Press. So these are the reference books. You can go through it. Now in the introduction, I would like to introduce what is the analysis. Analysis, in the disconnection approach, we have to retro-analysis first and then synthesis. So in the analysis, first is we have to recognize the functional group in the target molecules, and the second step is disconnect by the method corresponding to no and reliable reaction. The third is repeat as necessary to reach the available starting material. In the next is synthesis, write out the plan according to the analysis, adding reagent and conditions, modifying the plan according to the unexpected failure or success in the laboratory. So now we are going to start with MSc Final Paper 505, Unit 4th, Ring Synthesis. Introduction. The ring formation means intramolecular reaction between the two reactive sites in the same molecule. Usually intramolecular reactions are favored kinetically over intermolecular reaction for a reason of entropy. Because the two reactive sites are part of the same molecule and there is no need for a bimolecular collision. This factor is greatest in the three-membered ring formation, where the ends of the reagent first are always close, and for five-membered ring formation, where the natural motion of second brings the reactive groups into the bonding distances. Now, introduction. Organic synthesis is the process of building the organic molecules from the simple precursor. Retrosynthetic approach or analysis. Planning a organic synthesis or disconnection approach. It is a technique for solving the problem in the planning of organic synthesis. This achieved by transforming a target molecule, generally abbreviated as the TM, into the simple precursor structure without assumption regarding the starting material. So target molecule is first converted into the first precursor, which will be converted into the second precursor, then two steps, and then the starting compound. And you can see here we use the open arrow mark. That is a hypothetical one, and we consider that we can approach through this retrosynthetic for the formation of organic compounds. For example, a nucleophile and a electrophile, and the carbon is attached with this, the first, and this nucleophile is giving the electron to the electrophile and forming a carbon-carbon bond. Or you can have the nucleophile separated by electrophile with the 3 carbon atoms, then you have 3 carbon atoms here and nucleophile and electrophile forming the second, a 5-membered ring. The 6th ring formation is kinetically favored, but the problem here as for larger ring is that rotation brings the reactive molecule ends to close the 3, third one this, and unfolding of the chain is needed before the bonding can occur. So you can see this is a easy formation as compared to this. So 1, 2, 3, 4. It is separated by the 4 carbon atom. So you can have a 4 plus nucleophile and electrophile, a 6-membered ring, or you can see by the rotation the nucleophile can come closer to the electrophile forming a 5-membered ring compound, compound 3, and then there is a expansion in the ring forming a 6-membered compound. The 4-membered ring's formation is uniquely slow. The chain normally adopts a Now, next we are taking the factors affecting the ring formation. Suppose you are having the ring size 3, and this is the kinetic factor and this is the thermolytic factor. So if your ring size is 3, then it is kinetically favored 3 times and thermodynamically it is not suitable. For a 4-membered ring, it is neither kinetically factor favoring it and nor the thermodynamic factor favoring it for the ring formation. The 5-membered rings, kinetically it is favored somewhat more as compared to the thermodynamic, and in the 6-membered ring it is reverse as compared of the 5-membered rings, that is kinetically it is favored one time and thermodynamically it is favored twice. So a 5-membered ring will be kinetically favored for the formation over the thermodynamic factor, and in the 6-membered ring thermodynamic factor will be dominated over the kinetic factor. Taking both the factor into the account, 5, 6 and 7-membered ring, and in the 7-membered rings they are equally favored. Rings are easy to make. 3-membered rings are easy to make but often break down again under the condition of their formation, whilst from the membered rings are uniquely awkward and often need a special method. So here are the some introduction about the factors affecting the formation. Thank you. Next we will take the 3-membered ring in the next lecture. Thanks.